Be ready with your copy. Good evening. Hello everyone. Hope all of you have done Coulomb's law and sums related to Coulomb's law. Vector form of Coulomb's law. Importance of vector form was also an important topic in Coulomb's law, because it will help you to find the resultant force acting on a particle when many forces are there, charged particle obviously. This time, Coulomb's law that force of attraction or repulsion, whatever you told, between two stationary charges, the formula is going to be a little bit modified. In vacuum, we have seen that A vacuum equal to Q1 Q2 by 4 pi 0 R square. This is 0, you know. Permittivity of free space, its value is 10 to the power minus 12 SI unit. And scalar form you must have seen. A vacuum equal to 9 into 10 to the power 9 Q1 Q2 by R square. Question is, why modification of this formula required? Very simple. Because this is in vacuum. Medium may not be vacuum always. It may be water. Maybe between two charges, we have kept a medium which is filled with oil. Oil, water, whatever may be there, due to the change of medium, due to the change of medium, the formula will change. The two charges will experience less force in a medium other than vacuum. In vacuum, this is the maximum force, I will say that. But it is observed that if the medium, when the medium is here, if the medium is water, then it is found that if water will be a vacuum by it. This is experimental observation. Similarly, if the medium is oil, this is again going to be changed. So the formula needs to be modified. How it can be modified? Two terms are there, that is permittivity of the medium and relative permittivity or dielectric constant. But the permittivity, initially I am telling you, for vacuum or medium, that will be referred as absolute permittivity. It means we are not going to compare anything over there. Just in the medium, what will be the force? Relative permittivity, dielectric constant, it matters. So how does it matter? Let me explain. Suppose between two stationary same charges, whatever you have taken, Q1 and Q2, this is not done in vacuum. In a medium of permittivity, I will say absolute permittivity, in a medium of permittivity or absolute permittivity epsilon, the F medium will take this form by using Coulomb's law only, that is 1 by 4 pi epsilon Q1 Q2 by R square. This epsilon is referred as absolute permittivity. So this is in medium. We refer this one as number 1 or this one. Number 1 and this is number 2. This is medium other than air. Maybe water, maybe oil, maybe wax, whatever. These are all dielectric medium. In a dielectric medium, force will reduce. Okay. Now, if we compare the force in vacuum and force in medium, then just divide 1 by 2. What do you get? Dividing 1 by 2, we get a vacuum by F medium. This is our number 1. Q1 Q2 by this divided by Q1 Q2 by 4 pi epsilon R square. So this will be epsilon by epsilon 0. Rest get cancelled. F vacuum by F medium now has this form. Okay. This will be referring as PR or K. That is called relative permittivity or dielectric constant. This you can refer as dielectric constant also. For dielectric permittivity we use here. For dielectric constant, same term, we write K. So how does it matter if I say that the value of K in wax equal to 3, oil. Suppose in a oil the value of K equal to 3. Or in a medium, if for oil you are not able to accept, if K equal to 3, what do you get? A vacuum by A medium will be 3. So A medium will be what? A vacuum by 3. Okay. So the force of interaction reduces by that time, which is permittivity, relative permittivity or dielectric constant of the medium. Now, what actually dielectric constant does, in between two charges, there was vacuum or air. In between two charges, now there is a medium. Okay? This is not air. As soon as the medium is changed other than vacuum, the amount of force of attraction or repulsion is changed. So if you are filling up the space between two charges, then it is going to affect the force of interaction between two charges. So I am using that means it has some practical application. Definitely, I will be discussing its application in details after finishing capacitor concept. Practical application you will find there, that when you when you use this medium, it can store more energy. The medium can store more energy due to two charges. But that we are not discussing now. We are just discussing how force is affected. We want to decrease the force. Then we decrease the dielectric medium. Okay? Now, suppose the value of dielectric constant of a medium equal to 2. If K equal to 2, what will be the separation between two charges to experience the same force? So distance matters. If K equal to 2, yes, because no, not 1/4. I am telling you why not 1/4. Because initial separation is say R. Now it was in vacuum. Epsilon 0 is there. We are taking K equal to 2. Dielectric medium is equal to 2. Formula here is what? Suppose this distance R and this one R dash. This one R and this one R dash. A vacuum is what? Q1 Q2 by 4 pi 0 R square. In this medium, F medium will be what? Q1 Q2 by 4 pi. Formula how do you write? Just epsilon 0 into K. Because if you say that I will not write epsilon 0 or K, you have to write the permittivity epsilon. But that epsilon is what? K equal to epsilon by epsilon 0. So epsilon going to be K into epsilon 0. So Coulomb's law has this form now. F medium equal to what? Q1 Q2 by, this is R dash. Not R, not same R. R dash. So it will be 4 pi K epsilon 0 R dash square. I hope you agree. A vacuum is this. F medium is this. The value of K will put. K equal to 2 given. So definitely we have to adjust the distance to experience the same force. How much adjustment is required? Just compare these two. Given that a vacuum equal to F medium, this implies Q1 Q2 by 4 pi K epsilon 0 R dash square. So all terms get cancelled except K and R dash square. So R dash will be R by K root K. So R by root 2. Okay. So distance now has to be decreased to experience the same force. What does it prove? If you keep the same separation, then force is reduced. This is the effect of dielectric constant. This is the effect of change of medium in between two charges. Whenever you change the medium, something happens between two charges, it will reduce the force. Okay? So R dash will be R by root 2. Now, if there is a statement like this, if dielectric constant of water be 80, what does it mean? Dielectric constant of water is 80. Explain its meaning. This I am telling in details because you are going to solve two brilliant sums based on this. We will relate class 11 physics also. Yes. Explain the meaning of this statement, dielectric constant of water 8. By definition, a vacuum by F medium equal to K. So, F medium means F water will be a vacuum by K, that is 8. Therefore, the force between two stationary charges reduced to one by 80th time 1 by 80th time as they experience when they are separated by the same distance as that in air. Force between two stationary charges, it may be attraction, may be repulsion, reduced to 1 by 80th time as they experience when they are separated by the same distance in air. First. Understood? If they ask you what do you mean by the statement dielectric constant of water of a medium is K, this is the same. It will be reduced to 1 by kth time of the force in air. Correct? Now, let us solve two very challenging questions. Let me ask you from the worksheet. I have already shared with you, sharing here also again. Number 5 and 6.
Dielectric constant in 1 by root decrease to the 1 by root 2 and root
1 by root 2. Distance becomes 1 by root. You avoid the confusion. State is reduced to, it has become r dash equal to r by root 2, no? So reduced to 1 by root 2 time the value is, or reduced by root 2 time. Same state, same meaning. It is reduced to 1 by root 2 time or reduced by root 2 time. Reduced to or reduced by. Reduced to 1 by root 2 time. Reduced by means root 2 times. Let us solve this problem number 5. Two identically charged spheres. We have done lots of sums in the last session. Let us solve it now. Things makes an angle 30 degrees each other. When suspended in a liquid of density, the angle remains the same. What is the dielectric constant? they are identically charged, charge B equal to Q. Okay? 30 degree with each other. This 30 degree where? This 30 degree is in air. Okay? So in terms of angle of divergence, you have done something. This angle becomes 15 degree. Tension BT, weight mg acting downward. Force of repulsion between two similar charges will be this way. Then this angle theta 15 degree. So this T has two components. That vertically upward how much? And this way T sine 15. Isn't it? The distance B equal to R. So this part will be R by 2. Length of strings be L each. So force of repulsion is balanced by what? Force of repulsion. It is balanced by the component of tension. So Fr equal to what? K Q into Q by R square. In air only you said. So the value of K will be 1 by, this is number 1, and this Fr is being balanced by T sine 15 degree. Am I clear? Tension as a component. Two charges due to repelling force trying to be separated. Now tension's component T sine 15 will be balancing the repelling force. Otherwise they will fire, The cords become vertical due to repelling force. And weight mg also. T cos 15, this will be equal to mg. So dividing 1 by 2, yes, buoyant force there, medium's dielectric constant is there. So it will be q square by 4 pi E0 mg r square. Alright, there is no confusion in it. All of you got it? Now it is going to be submerged in a liquid of density given 1600 kg per meter. Here 1600 and liquid 800. Oh. So same diagram I am keeping side by side. This is in vacuum. In medium of permittivity K, relative permittivity or dielectric constant K, what going to happen? Same diagram will be there, just mg will be a little bit balanced by the buoyant force also, isn't it? Why does the buoyant force act? Buoyant force will act upward direction. You know, this is how much I am writing U. Remaining things remains the same. This is 15. So this way it will be 15 degree. T has component, weight mg downward. This is T sine 15. This is repelling force. Effort, upward direction, what are the forces acting? U and T cos 15 degree. I think you all understand. Similar is the case here also. I am not drawing it here. Okay. Same thing acting here. T sine 15, then U plus T cos 15, then mg, and here it will be Fr. So for equilibrium, just modify the formula by the factor K. Fr will be what? This time tension you write T dash because same tension won't be there, isn't it? T dash sine 15 is 4 pi K epsilon 0 R square. You agree or not? K is 0. I showed you the modification of the formula. In place of epsilon, you write this thing. And U plus T dash cos 15 equal to mg. Am I correct? Okay. Now let us write the value of U and mg. U is what? I remind you, rho be the density of the substance. Sigma be the density of the liquid. Okay. Then U will be what? V into sigma into G. I hope this you have not forgotten. Remember, buoyant force is volume submerged because the whole thing is submerged in a liquid, isn't it? Or the ball only. This ball they have told, or the whole medium, check once. This ball is submerged in a liquid of density given. So upthrust U is what? V sigma G. Mg is what? Then mg will be V into rho into G. Because rho is the density of the body, volume into density into G will be the weight. Am I correct? V stands for volume. So little bit modification I am doing here. T dash equal to mg minus u. I will be putting mg and u both later. This is our number 6. Okay. Previously we got tan 15 equal to this thing. Now divide. Dividing 5 by 6. This is 4, yes, 4. Dividing 4 by 6. What do I get? Again, tan 15 equal to 4 pi k E0 R square mg minus u. Am I correct? This is your number 7. Tan 15 initially how much you got? Tan 15 initially q square by 4 pi E0 mg r square. This is our initial calculation. Tan 15 remain the same. So from 3 and 7, what do I get? 3 and 7 you just compare. 4 pi k E0 r square mg minus u equal to this thing. Pi 0 mg r square. Tan 15 same, no? So these two getting cancelled. 4 pi 0 also r square getting cancelled. So k going to be what? Mg divided by, am I correct? I hope you have understood. Just divide. Now what we'll do, we'll put the value of mg and u over there. So k will be what? Rho g so 4 pi r cube g getting cancelled. Rho by rho minus sigma. Isn't it? What's the value of rho here? Just check once. Two densities are given. One of them is 800. Check once. Coming 1. It cannot be 1. Negative not. Rho is what? Density of body. Density of body is larger than density of liquid. 1600. So this one 1600. No, not 1. 2 is. Rho is the density of body. I have written clearly here. Check. Density of the substance and sigma density of liquid. So this is rho by 1600 by, therefore k equal to 2. Alright. I hope you will be able to use this concept to solve number 6. Okay. We'll discuss more on dielectric constant in future. I will explain what's the utility in our daily life, dielectric constant, in case of capacitor, how it helps to store energy. But today on dielectric constant is still this one. We are going to start electric field now. But after break, yes, you better do it now.